Hello dear viewer, welcome back. This is Lorenzo and you're watching KSP to Mars, episode 42, in which we explore the meaning of life, the universe and everything. And we do so of course by sending a probe to Saturn, which is represented in the game by the good planet Dres. And I've taken the liberty of launching the probe and setting up the encounter already. It's the exact same probe as from yesterday's episode, the one that's currently on the way to Jupiter. Let's see if we can find that. Look at that, this is the one that I just launched, this horribly mangled contraption. And yesterday we lost one of these transceivers and today we did not. So that's progress, I assume. Let's have a look. Here we have, where is our probe that's on the way to Jupiter? That should be in system somewhere around here. Is this one already? Let's have a look. It is this one, the Jupiter Science Probe. That, my god, that went quite far in the first few days. It's always a little bit counterintuitive with these ellipses. The first bit always goes way faster than the second bit. For example, this Uranus probe, if we look at the alarm clock, that will arrive in 9 years and 60 days. When it left, that was 11 days, yet it has already traveled more than half the distance, so still 9 years to go until it meets up with Uranus, which is represented by Minmus here. Now, the probe to Saturn, that's no doozy either. That will take 6.5 years, a little bit more than that even, so we can leave that behind until a point in the future. Of course, it's powered by the chemical upper stage. There's a little bit of fuel left in that, and the rest has the microwave power receivers. Now at this point, the microwave power transmitter station is a little bit underpowered. It transfers a few megawatts, sure, but nothing enough to enable stellar propulsion levels. Of course, in 6 years this might very well change, so this probe and the Jupiter one is in some way future-proof. This, however, is not what I'm going to do this episode. Well, I did it already, but it's not what the episode's about. We are preparing to send people to Mars. Now, they're not going to go in for a landing, but there are going to be Kerbals around Mars, if all goes well. What I'm thinking is to send a crewed mission that will be a 2-launch affair that will dock together in Earth orbit, and then a second launch, or a third launch depending on how you look at it, will be the care package that will have an excursion vehicle so they can take surface samples of Phobos and Deimos, the Martian moons, and possibly, weight permitting, even set down on the red planet. Or if they're not going to be able to set down manned, at least there will be another lander probe. Well, this is the probe I just launched. What I wanted to show you is something else. Where do we have it? The Mars Lab 1. Now it's a science lab, the 2.5 tons KSP Interstellar Science Lab, and let's scroll up and have a look at that. Here we are, the science lab with of course a Mark III capsule on it. This is reminiscent of the Orion spacecraft that is, well, depending on how you look at it, either scrubbed from the NASA plans or repurposed as the the MPCV, the Multipurpose Crew Vehicle, that's slated to launch in 2017. Now we have this lab here, a ring of batteries, some heat radiators and the small nuclear power source for, well, power of course. And we have here a helium cryostat, it's basically a tank of liquid helium, and the Deep Space Infrared Telescope. Well, we've not scienced anything with this instrument yet, so hopefully on the way there we can do some useful science that way. Now, this is just about the max of the launch vehicle's, well, launch capacity, and it carries a fuel tank, and then the second launch will carry a larger fuel tank and some nuclear engines to actually get it to Mars. So this is the one I'm going to launch now. Well, I'm going to make some dinner first and then I'm going to launch that. So I will see you when we have this in space. And there we have our beautiful Mars laboratory in the final stage of orbital insertion. The upper stage is burning and it needs another few hundred meters per second. The heat radiators are deployed, and as soon as we are stably in orbit we will be doing a deep field scan with this helium-cooled telescope, after which we will of course launch the drive stage for the journey to Mars. So let's have a look here. We are, well, 350 by 259. Yeah, that sounds like a good orbit. And I have miscalculated a little bit. Well, we have some extra fuel in this stage that's not going anywhere. This is wasted. So I'm going to leave it here. I could use the fuel to raise this orbit a little bit, but then the other fuel that's going to be lifted will have to be lifted to that higher orbit also, and that is going to carry a nuclear engine, so it's probably beneficial to have that firing as soon as possible while attached to the station. So I'm going to leave it in this fairly low orbit until until the other guys, the other Kerbals will show up. Look, I have 2 solar panels installed here, and they are at this point completely useless because we also have the nuclear reactor. This, however, is going to be a long-term mission. This laboratory will remain in orbit around Mars for quite a while, and it's conceivable that the uranium might run out, and at that point we have solar panels so as not to be completely without energy. I have 1 docking port here for refueling connections, possible expansions of the station, although that is not planned because this will be out at Mars, far beyond the reach of easy refueling missions. But I digress. Let us do the deep field scan, and just for flavor I'm going to angle the telescope away from the Earth, of course, otherwise we shall only image the Earth, which, well, is not quite the point. So performance 6.1%, how is that? I don't know, let's do the deep field survey anyway. Oh, it's just doing it? Ah, damn it. I was hoping for a science report that, you know, would pop up one of these screens and give me a lot of science, but this is just going to give me 0.03 science per day, and I think the performance is so low because, well, we're not in an ideal environment. We are, well, not in deep space, we're in low Earth orbit, so I'm just going to leave it running anyway. You can see here the G-lens, the gravitational lensing experiment. That requires a distance of 548 astronomical units, and 1 astronomical unit is where we are now. This references distance from the Sun, and 1 AU is the distance of the Earth to the Sun. So it's this bit times 550. It's about, if I recall, 10 times further out than Pluto, possibly more. Pluto, could that be... No, Pluto is not at 50 AU, is it? Well, the Earth is here. Pluto could be at 50 AU. It's hard to estimate from here. We get, order of magnitude, we get million giga, we get 5.5 terameters, and the Earth is at 100 gigameters. So that's 3 orders of magnitude. Am I counting that correctly? Yeah, I think anyway it's about 10 to 20 times farther out than Pluto, which of course is very far out. We might send one of these telescopes that far out someday in the future, but they don't operate robotically. They either need a laboratory with Kerbals in it, of course they also need the helium and the nuclear reactor, so it doesn't lend itself for a lightweight probe with one of these high ISP propulsion systems. We need to send a heavy spacecraft way to the edge of the solar system, even beyond the edge of the solar system, I think. So yeah, that's for the future when we have ultra high efficient propulsion, probably the inertial fusion drive, or if we do ever get that far, the warp drive, of course. That would be a nice use to put this telescope in a solar orbit that high. For now, our laboratory is full of fuel. We can go ahead and separate this tank here, decouple this, and wait. Is it a docking port on the other? No. Oh, god damn it. You're seeing that? The docking port was attached upside down by yours truly and is wonderfully attached on the wrong thing. What? Oh, that is terrible. That means we're definitely not going to be able to attach anything in line here on the station. We have only this docking port. And I think this is pretty much in the center of mass, because this tank is very heavy, but these things aren't lightweight either, and they're extended a little bit on the balance. So I could try and rig up a pusher thingy here, and use that to push the laboratory to Mars. I'm definitely going to attempt that. Oh, that is a bummer. Jesus. Of course, I'm also going to get some distance because this is crazy close to this defunct upper stage. There we go. Now at least we're away from this stage. Wow, I'm going to have to revise this pusher mechanism a bit. It will probably include a lot of reaction wheels and some highly gimbalable engines. Well, I'm going to go to the VAB and make that. See you when I figure that out. Right, and once more I've taken the liberty of avoiding the VAB and just showing you what I came up with in space. Unfortunately, it is dark again, and we're currently coming in for a docking maneuver on the Mars lab on the side with what amounts to basically a fuel tank, some control surfaces, well not surfaces but some control things, the big SAS module comes to mind, and a nuclear engine here. Now of course, because wait, let me disable these control systems so the magnetic thing can dock us. Of course we have now plugged into the, well, before I talk on, let's take this opportunity to time warp into the sunshine so that I can show you what I'm on about. There we go. That's better. Look, here we have our engine module, and I'm proud to say that I managed to deliver it as good as full. It has consumed 3 units of liquid fuel. I got it super close with just the upper stage. I think that's still floating somewhere. Anyway, I had to cancel about 10 meters per second with this nuclear engine, and the rest I did with the monopropellant, which is still almost full. Now of course this is not the most ideal arrangement for a drive section. This is basically pushing everything sideways. I do have a reaction control wheel here, the torque of the pod here, and of course the gimbal of the engine to counteract any undue yawing effects. If all that doesn't work out, then I have the option of jettisoning this module, the nuclear reactor, the helium cryostat and the telescope, and attach the drive section here on the front. That would make it a nice spindly arrangement capable of being pushed easily. Unfortunately, this nuclear reactor is docked single-sidedly, so once we ditch that, it's gone forever. And that would mean another launch to, well, provide power for the system that could then plug in here to the side. And while that would still unbalance things, it wouldn't be quite so bad. So it really would be best for everything and everyone if this arrangement worked, because then we are now flight ready to go to Mars. So what we're going to do, the launch window for Mars is not quite up yet, but we're going to see if we can raise our orbit to a circular 500 kilometer orbit, and that should serve as a good enough test to, well, to see if we can actually do this, if this whole vessel is controllable and maneuverable. It does turn very quickly. That is a good sign, and we can ask, we have only 4 kilometers per second of delta V. I wonder if that's counting this fuel. I don't think it is, because there is no way for it to flow. I hope it doesn't count this fuel, because otherwise we have quite a low amount of delta V, really. So maybe if I disable this, does then the readout change? No. Does it change if I disable this? No. So those readouts don't really do anything. Anyway, this reading is still very imprecise because it says the specific impulse is 480. That's the average of this engine and this one. So even if it is counting all the fuel, we have almost we have a lot more, because the specific impulse, the actual specific impulse, is a lot higher. So I think we are good for a Mars insertion. And let's first try now to raise the orbit, shall we? I'm going to aim prograde. Try locking the SAS on and firing up this engine. Let's see, we are at half thrust now, and I can't really keep it on course. At a quarter thrust though, at 1/3, the control authority is good enough to lock in a heading, basically. Will the SAS be smart enough to do that as well? Because if that's the case, then I can just leave it. No, I'm going to have to keep my own fingers on the controls here. I don't know how that is, but the SAS, it doesn't, well, in situations where you need full control authority to maintain a heading, it doesn't really do it. And I don't know why. So this is probably going to be a very tedious burn for me, because it's going to have to be a manual one and controlled all the way. Let's see what happens if I completely open up the engine. I can just about maintain heading, but not quite. This, however, will get better if I burn half a tank of fuel, transfer the fuel from here to there, because then this whole assembly will be lighter. Although we are turning that way, that means that this bit is heavier, which means that lightening this is not necessarily a smart move. Yeah, so this is going to be a bit of a labored burn, but fortunately it will be very much possible. So that's the good news, and I'm gonna stick with that good news for now. Yeah, this will definitely take a while. Let's see how long it tells me. I wonder why it tells me that my specific impulse is now 409.7 and now 388. This thing is confused, I can tell you that. This assembly is not something the Kerbal engineer has well, experience with or has planned for. So I'm going to leave this for now. Our Mars window will open up in either 79 days or 98 days. I don't know why. This alarm is from a while ago, and a more recent one backed it at 79 days. Perhaps if I look at it now, it will be something else again. No, it's sticking with, well, it's now 76 days. So I'm going to go out on a limb and guess that the positions Mars and Earth are in now is that we actually have quite a long transfer window where they actually, it's fine to launch from anywhere between 80 days to 100 days from now, because obviously the game isn't making up its mind when the ideal time comes. So I'm going to time forward to this point and then see if we can indeed launch there. So yeah, let's do that now. I'll time warp forward and set up that maneuver node so you can have a look at it. Of course, before we're going to proceed to the Mars launch window, we have a care package to launch, and this is in the process of being launched, and I'm showing it to you here because I want you to be here for the great reveal. And there we go. See, I'm rather proud of this care package. It is very big and complicated, and it has everything a budding Mars crew needs. It has on top here a manned, currently unmanned, Martian excursion vehicle. This will allow the, well, one crew member of the station to go hopping around the moons, Phobos and Deimos, taking surface samples and doing science. Then we have two small-sized lander probes here. They are ion powered, and because they're very light and they're intended for the very, very low gravity worlds of Phobos and Deimos as well, I am hoping that they can land with just ion power and 3 solar panels. They do carry a battery for a little bit of backup, but those landings could prove hairy. Then we have 2 unmanned Mars landers. These are the only things in this expedition that are intended to land on the planet. They have the inflatable heat shields and they carry 4 parachutes, landing legs and a full suite of science experiments. So 2 shots for a landing on Mars and a lot of science to do in the surrounding system. These heat shields are inflatable. This top heat shield will inflate and will in fact cover all the other probes, so that this whole assembly, when it gets to Mars, can do an aerobraking pass, and that will be necessary because the delta V on this whole contraption is fairly limited. By my estimation, we should have just enough to make it to Mars, but nowhere near enough to break into orbit and do things there. So we definitely need the aerobraking pass there. The challenge will of course be to estimate the height above the surface to do that pass at. I have not figured that one out yet. We're gonna guess something to do that, honestly. So that's going to be the most challenging bit for this care package. Although this unmanned lander, well, and these, they do have fuel tanks. In a pickle, they could transfer their fuel to the nuclear stage and then, well, either proceed with less or be scrubbed altogether. So there is a little bit of wiggle room there, but not a whole lot. I'm going to continue this orbital insertion, and I will show you then the transfer window for the Mars laboratory, and then we'll go on our way. We'll start on our way to Mars. Yeah. And here we are again, and before I lead off with what we're going to do, first my apologies, this is the second time in this video where I say I'm going to cut forward to a certain point and then proceed to do something completely different. Where you're expecting to see the Mars probe and care package, or the laboratory and the care package set off, we are instead with a wholly different craft. And if you are an avid viewer of this series, which I hope you are, you will recognize this as the Saturn Science Probe, which is identical to the Jupiter Science Probe. But this is the Saturn one, and it happens to have its course correction moment already. It was just 2 days outstanding, look at that. The Kerbin to Mars window is still at 76 days, so that hasn't changed much. And this was hidden from the alarm clock window because the probe was still in Earth's sphere of influence. Oh yeah, and it's unbalanced, so it's hard to control, just like the Mars laboratory will be. I'm showing you this because, well, it's a 3.5 km/s burn to do a 7-degree inclination change around the Sun and actually put it on a collision course, which is the most accurate interplanetary rendezvous you can have, really, if you look at it that way. And we are going to test out our beamed power propulsion system, of course, when this chemical stage with its finicky... it's being difficult to control because I think this is unbalanced somehow. Well, that's not hard to say, really, so it definitely is unbalanced. As soon as that runs out, we are going to see if we can eke out 3 km/s out of this beamed power propulsion system, and we should, because according to the Kerbal engineer there's 13,000 delta V's of that left. So let's ditch this stage first and foremost, and then proceed. Oh, I might have built a Kraken drive that turns all by itself, but I'm going to lock it here, and I should have enough control authority to fix that, because this craft is light. I'm going to proceed by activating all these receivers, and the beauty is they only open when there is a, well, there is a way of receiving power. So this one is already aimed correctly, that's wonderful. Let's have a look at that. It's receiving 15 megawatts. That's not a lot. Also, something I see here is that this receiver is very much in the firing path of the engine. I had not thought of that. So first I'm going to rotate the craft, see if we can increase the amount of power received. It does seem that we can, although 17 appears to be the maximum amount of power. That is ever so slightly disappointing, because that means our burn will take a very long time. The good news is that this power receiver doesn't mind that it's being thrusted through, so that's fine. The, well, somewhat worse news is that this burn is going to take 3 hours. And let's see, in that time, well, of course we're not going to see the Earth, it's very far away. In that time it's very possible that we are going to lose coverage of our, well, we're going to lose line of sight to our power transmitting station. However, the satellites are put in wide orbits around Earth. They should, if I'm correct, ensure that basically pointing at the planet will be enough to, well, to do something to receive power. So hopefully any losses in signal, losses in power, will be intermittent at worst. So I'm going to go ahead and activate the time acceleration, wait for just under an hour while I do some useful things around the house or something, and then I will go and do the Mars thing. So I'm going to let this run and I'll show you the results. See you in a few hours, and let's see if there's any science we can do. I think all of this has been done before. But hey, you never know, it doesn't hurt to double check. No temperature scan, and the magnetosphere, I'm rather sure that has been done also. Yeah. So nothing to do but weight and thrust. What's our current thrust to weight ratio? It's 0.001. And we have 13.5 kilometers per second of delta V remaining in this. The good news, the very, very good news, is that this system is in fact working, and that's great. We're connecting directly to the power station for 17 megawatts. I don't know if distance is a factor or if it's just that it's not aimed quite directly let's see, if we have a look at the map view, can we see what way the Earth would be? Yeah, it would be pretty much directly behind. Let's see if we can set that as a target. Well, the moon, that should serve. Yeah, see, it's pretty much, well, I have no idea where it is really. This dish is at least not pointing towards it perfectly. Should we get a better signal, say for whatever reason, maybe the far out probe is a little bit angled, still even at this distance, I don't think it will be, but if we get a little bit more power, the burn will get shorter, so I'm going to check back every now and then. Anyway, I told you already, I'm going to skip time forwards until that happens, and then we're going to cut back to the Mars program. So see you in a bit, where I'll undoubtedly have another launcher surprise or whatever in store for you. And there we are, 3 kilometers per second later, 7 degrees tilt in the plane around the sun further, and we have a periapsis with DRESS, which is of course Saturn, of 166,000 kilometers, which should be near enough to perform course corrections and the such. It won't go any lower because our plane is still inclined by 0.3 degrees, and well, that is actually an overshoot on the burn there, probably because of some wobble due to the unbalanced nature of the craft. I did manage to rotate it a little bit to get a whopping 32 megawatts from somewhere among the stars over there, which is of course the power station around the Earth, and that made the burn take only about an hour, so that was wonderful and very welcome. With that said, this probe will arrive in about 6 years and 100 days, so not quite yet. With that said, let's move on to the Kerbin Duna launch window. In fact, let's time warp from here and then switch to the Mars laboratory for the burn. So I'm going to go ahead and time warp that time away, and then I'll move over to that ship. So yeah, this is as good a point as any, and I shall do that now. And here we are at the end of a fairly tedious Mars injection burning session. You can see the craft wobbling around on its SAS control. The thrust from this nuclear engine is very low because the center of mass is somewhere here, which causes the thing to, well, rotate if I thrust too harshly. It has taken 3 orbits about Kerbin, about Earth, and every time at the periapsis I applied some thrust, imparting about a kilometer per second of delta V each time, and now we have an orbit that is just about the height, or just has an apoapsis just about at Mars's level. I'm going to finish this burn. It's about 30 meters per second more, although I'm not quite sure that will in fact be the case. It doesn't seem like 35 meters per second can bridge this gap. Maybe it can, or possibly the whole thing has been thrown out of whack a little bit by the careening and veering Mars vehicle. Look, these trajectories are not quite equal. It doesn't really matter though, because we are going to have to do a course correction anyway. We're a few degrees off the mark plane-wise, so I'm going to put a Kerbal alarm clock alarm at the ascending node here, and we will fine-tune the trajectory there. Before we do that though, it is fast time to switch to the care package and send that on its way. So let's go ahead and do that, and just take a look what kind of mayhem the map view has become with all the probes and things everywhere. That's the way we like to see it. And let's, as I said, have a look at the care package. The care package, here we are, switch to that, which we have here, and fortunately has a little bit more sane propulsion system. It has a good bit of delta V remaining in the upper stage, well, not that good a bit, like 400 meters per second, and then we just switch over to the nuclear engine, which is nicely in line with the center of mass, so I'm expecting no problems at all with this going to Mars. So let's quickly set up a maneuver node for that and start the burn, and then we can finish up later. This will be the end of the episode. Next episode will focus on, well, getting to Mars and playing around with this payload. The ascending descending node plane corrections, I will not show those to you because that's just more burning and will very quickly get rather tedious. So the next episode will commence, if all goes well, that is, with a with a Mars encounter, where I hope that the lab will in fact be able to get into orbit. That will be a little bit of a problem because the nuclear engine is limited to such a low amount of thrust because of the imbalance that it might be hard to get into an orbit in one go. Yeah. So we'll see how that works out. If I can get my maneuver node back here. Put this one here, and this will of course also need a mid-course plane correction to actually encounter the red planet. But what I want to do most of all is just start the burn. Ooh, this has a very, very, very weak amount of rotational control. So yeah, let's fast forward to that maneuver node. I will start burning about, well, what shall we do? About 7 minutes in advance, because this big engine of course will give the whole spaceship a big kick. But when that is all said and done, it will still need to accelerate for a fair while on the nuclear engine. I am rather looking forward to playing around with this package at Mars. The ionic powered moon landers, the big aerobraking heat shield, the crew capsule that can be manned and landed on the moons, and of course the atmospheric landers here. Lots and lots of toys to play with. That should be good. For now though, let's first start that injection burn as soon as we go over that blue marker. What I always do is open the orbital tab to see if I'm not being too gutsy than by burning towards the planet. If I do that too much, I could lower the periapsis to go down into the atmosphere, which of course is counterproductive. So I have this window here to see how that's going. It is lowering, it is falling, but not very rapidly, and as soon as we switch to the nuclear engine, that's not going to be able to put a dent in it. So let this remainder of the upper stage of our big launch vehicle do its final job, and then we can ditch that and move on with the nuclear option. Yeah. So what I'm going to do again, because I'm a little bit afraid of these shrouds exploding into my fuel tanks, is decoupling from here and activating the engine from here as well. And see that acceleration is a fair bit lower than it was while under mainsail thrust. Fortunately, as I said before, this craft is symmetrical, so I can just punch the nuclear engine as hard as it will go and thrust straight and true, which of course helps tremendously. So I'm going to do this burn, do the corrections, and then for the next episode we will have these payloads encountering Mars and, well, doing their stuff really. So I was Lorenzo, thanks for watching. I want you to do all the good stuff like subscribing, liking, leaving comments. I do like my fan mail and I always try and respond to it. At least if there's something that's like worth responding to. If you say amazing video, I can say yes. I might not do that, but if you have a question or a comment, put them down and we'll have a nice little conversation going on. I do like that. And see you tomorrow for the Mars encounter, the care package, the laboratory, and the deep space telescope, which so far has been nothing but a headache, because if we could just chuck that away, the drive stage could be attached inline. Anyway, see you tomorrow. I've been going on for far too long already. This was Lorenzo. Good night.